Hello, geometry people. This is the introduction to Topic C, Day 1, Intro to Transformations. It's a flipped lesson. And let's go over some of the vocabulary, the introductory vocabulary. First of all, transformations, as you can see, take points in the plane as inputs, and it applies a particular rule, as like a function rule. And it gives other points with new locations as outputs. This notation right here is the function notation. Okay, now the pre-image is the point before a transformation takes place. In terms of the functional notation, this right here, that represents your pre-image. The image is the resulting point. And with respect to the function notation, this here denoted P prime, that's what that apostrophe is, P prime, represents the image. Rigid transformation is a transformation that preserves size and the shape of a figure. So in other words, the pre-image and the image are exactly the same size, same shape. They're identical to one another. It's just that the image has been moved. And isometry is just another word for rigid transformation. These two are absolutely synonymous. Okay, so it's just another way of saying rigid transformation, aka also known as rigid transformation. A direct isometry versus an opposite isometry. Direct isometry preserves orientation. Orientation meaning the sequencing of the vertices. We'll obviously see more examples of that. An opposite isometry reverses the orientation. So the sequencing of the vertices changes. So for example, your pre-image might be a clockwise orientation. Let's say it's a triangle ABC and the vertices go clockwise. An opposite isometry then changes that to counterclockwise. And lastly, a dilation, which is not a rigid transformation because a dilation changes the size of an image. However, it does not change its shape. So it has the same shape, but just a different size. This is not rigid. And we'll talk more about those dilations in our next mod. Here are some of the properties that are preserved under transformations. Distance, which means the length of your segments. Pre-image and image have the exact same segment length. Angle measures are identical. Okay, so if you take a rectangle and you transform it, it's still a rectangle. It still has right angles. Parallelism. So if a pre-image has parallel sides and then you transform it, the sides will remain parallel. Collinearity. Points that are on the same line in the pre-image will be on the same line in the image. And then here's that orientation. Orientation, again, it's the sequencing. It's the letter ordering of vertices. Sometimes it's preserved. Sometimes it's not. It depends on the transformation. Hence the direct versus the opposite isometries from above. So let's talk a little bit about the three basic rigid transformations. These are the transformations that preserve, again, the size and shape. So there's three of them that are rigid. The rotations, reflections, and translations, which you've probably heard of in middle school. But a rotation is simply a turn about a fixed point. That fixed point, that's called the center of rotation. So right here, P is the center of rotation. And there's two directions you can rotate. There's a positive rotation and there's a negative rotation. So a positive rotation actually is going to go the opposite of what you would think it would go. Positive rotations go counterclockwise, where the negative rotation goes clockwise. So it's backwards from what you would expect. So in terms of our pre-image, triangle ABC, notice there's no apostrophes or notch marks. This is your pre-image here. It is going in that counterclockwise direction. So this is actually a positive rotation. Notice that this is, again, your center of rotation, and this is the angle of rotation right here. And we use this Greek letter called theta that represents the angle of rotation. So in this particular case, it looks to me like it would be a 90-degree counterclockwise rotation or a positive 90-degree rotation. How you can measure that very easily is just pick a pre-image point, such as C, right, like this right here. And if you notice where C prime is, which is here, it creates that right angle. And every single point rotates the exact same amount. Now, if you can imagine with your compass, point at P, pencil at C, you make this arc, you can see that C prime moves along that arc. If you put your pencil on A and you create that arc, A prime moves along that arc 90 degrees, and the same thing for B, moves to B prime along the same arc. Next, reflections is basically a flip. It's a mirror image. So one thing I want you to notice here is that this right here, this line M, that is the line of reflection. The line of reflection, you can probably tell me, looks like what? If you looked at CC prime, what would you say that M is? Well, based on the notch marks and the right angle, looks to me like the line of reflection is the perpendicular bisector of the pre-image and image segments. So CC prime, BB prime, and AA prime. These are your pre-image and image segments. This is your line of reflection, and it is the perpendicular bisector. Okay? So the line of reflection is the perpendicular bisector of pre-image, image segments. One thing that you need to take note of is the orientation of the vertices. So if you were to look at the pre-image and you start at A and you go alphabetical, A to B to C is going clockwise. Notice what happens on the reflection. A prime to B prime to C prime goes counterclockwise. So this right here reverses the orientation, which means, by definition, this is an opposite isometry, which reminds me, back up to the rotation here, the orientation from A to B to C is going counterclockwise, so is A prime to B prime to C prime going counterclockwise. So this one preserves orientation, and therefore, by definition, is a direct isometry. You can also call an opposite isometry indirect. Some people do that. The last rigid transformation that I'd like to talk about is the translations. And translation, as you know from middle school, is just a slide. Every single pre-image point slides in the exact same direction and the same distance. Okay, every single point. So, every point, pre-image point, let's say, moves in the exact same distance and direction. So if you look at this from A to A prime, it looks like it's kind of going in a southeast direction. So is C to C prime, and so is B to B prime. Okay? So they move in a, let's see, every pre-image point moves in the same direction and distance. Now, one thing you can see with the pre-image to image rays is that each and every single one of these is parallel to one another. Okay? Now these rays have special names. They're called translation vectors. So the translation vectors are parallel. And congruent, equal measure. That's that same distance. The orientation, as you can see, if you look at your pre-image from A to B to C is going counterclockwise. Well, so is A prime to B prime to C prime also going counterclockwise, which means the orientation is preserved. And by definition, this would be a direct isometry. And that's basically our lesson on the introduction to rigid transformations. Obviously, we'll go much more in depth with these 3 rigid transformations. But for now, that's it for me. Your homework is attached. Have a great night, and I'll see you tomorrow. Bye. Bye.